Hello and welcome live to the University of Sussex here in Brighton. This is engineering.
Engineering and Informatics at the University of Sussex.
Hello and welcome to the University of Sussex live here from Brighton, well, Hove actually. This is live from my living room because we're in lockdown special, and today we are going to do you a little bit of a virtual open day, the kind of thing that we'd love you to have seen had you been able to come here. Unfortunately we can't do that obviously because of the situation, so we're trying to give you the best opportunity you can to decide on where you want to do, where you want to go and what you want to do for your future. Now, down the line we have Ian. I'm just going to introduce you to him now. Hello Ian, how are you doing?
Hello Pat, hello Phil, nice to see you again.
Yeah, hello. We only did a show a few moments ago, so it's like we haven't seen each other for an entire 30 seconds. Now, if you want to text or iMessage or WhatsApp any questions, then we have a number for you to text at the bottom of the screen, I believe, and please don't call, because calling is a bit weird because I'd have to answer the phone while it's just not going to work. We do have a bit of an issue, I think, iMessaging back, so we can certainly WhatsApp back and I think text, but iMessage might be a bit difficult. So anyway, our aim is to try and do as much as we can on screen and offer you the answers on screen as much as possible. But now I'm going to hand to Ian to talk about the university.
Hello. So my name is Ian Wakeman. I'm a professor of software system here at the University of Sussex, and it's my pleasure to introduce you to the school itself. We are in Sussex, just outside Brighton, and what we can see here is the aerial shot of the the campus, and off towards the right-hand side, you can see where residences are. And in the centre, there are the academic buildings. And then on the far side, there is the football stadium of Brighton Hove Albion, the Amex Community Stadium. And I'll come back to that very shortly. Okay, so you'll be joining the University of Sussex, us, at a good time. We've got around 19,000 students on the campus. About 35% of them come from overseas. And over the short time that the university has been going, just over 50 years now, we've had the work for 3 Nobel Prizes and 1 Crawford Prize. The Crawford Prize is the equivalent of a Nobel Prize, but for biological sciences. And you can, of course, pick whatever rankings you want. One we particularly like at the moment is the Times Higher Education World Rankings, where the University of Sussex comes in 19th in the UK. Okay, and the most important thing, we're also the sunniest campus in the UK, probably. Okay, so what are you coming? What are you doing? You're coming to the University of Sussex to study engineering. Engineering is the study, yeah, it's buffered again. So the University of Sussex and engineering is a great place to actually learn about the theory that you use to actually then go and build the solution to the problems of the real world.
I think it's working. Hello everyone. Sorry, we had a barrage of people saying it didn't work. The problem was it was working at our end. We think there's a problem with YouTube and the music that we were using, so we're not going to play any more music anymore because it did this before. We do have licenses for all the music, but of course maybe YouTube's got a little bit confused between who owns what license and what, and then they keep bringing the feed off. So we are going to carry on from where we left off. And in a moment, I'm going to hand back over to Ian, but we've just got to restart all the presentation gear that we took off air just in case that was the fault. It turns out that what we will be doing later on in times is to route stuff actually via the Sussex servers. But at the moment, we've due to all the remote working and stuff that we need to do at Sussex, we've reorientated some of the servers so they don't quite work in the way that normally they do, but they're great for the students to be able to VNC in and do stuff. So we've been sort of battling against that, which is why we then used YouTube as the service provider for this one, but they're not really providing the service that we were paying for, except it's free, so we're not really paying for it. Anyway, now we might be able to get Ian back in a second, so I'm going to see if I can get Ian, see if he's down the line there. I think he's down there somewhere. Well, just waiting for him. Where is he? Hello, how are you doing?
Yeah, good.
Now Ian is actually a networks expert, actually. We don't have the presentation yet, so anyway, I do apologise to Network for the moment.
So yeah,
what is it that you've been doing?
So I've been sitting around watching the network work. So yeah, whilst we're here about actually doing this, I'm just going to have a little chat. So sort of we saw hopefully earlier sort of the Brighton Podium. One of the things that we do, and one of the great things about our faculty, is that we have the ability to actually sort of take our research out into the real world. This is our faculty now. Our 76 faculty are up there. They're all experts in their own research field. In particular, we have experts in artificial intelligence, in data science, in sort of thermodynamics, in sort of thermofluid mechanics, and much, much more. One of the great things is we do spin out what is spin out. As I said, my company, my own spin out, is in Crowd. We go to the stadium next door, and my research team and I, when you go to a football match, you try to use your phone in 35,000 people or more, you can't necessarily get a data connection out. So what we did is wrote software we put on the phone, so when you turn up to a football match, the phone makes connections to other phones in the crowd. And whilst you can't get a connection, there's someone in that network of phones who can. They suck down the updates of the app and push it out so that you can see the live scores and statistics. And that was so successful, we rolled it out into a company, and now employ over 50 people in the centre of Brighton working in sports, from athletics to sort of cricket to sort of rugby and so on. Okay, so the wonderful thing about having all these people work in the industry is that we can actually make connections with industrial companies to help you get a placement. So the industrial placement is an optional thing, typically between your second and third year, where you go out and work for a company for a year that allows you to basically build your CV, working with things like blue chip companies such as Jaguar, such as Ricardo, such as Rolls-Royce, or even smaller medium-sized enterprises. Our graduates go on and get good jobs. In one instance, so you would have seen, you've all got a mobile phone, and the mobile phone has got a chip in there that's produced by ARM Computing, and the Chief Executive Officer is one of our graduates, Simon Seegers. One of our more recent graduates, Lucy, this summer graduated last summer, and she produced a material that she builds from fish scales that's a perfectly sort of compostable, biodegradable plastic. These are great things, and she won the £30,000 Dyson Prize. And now we'd love to see you in September and help you to actually learn over the course of your degree for the next 3 years. Okay, thank you very much. So I'll hand back to Phil now.
Thank you very much. Now, I did instruct Mr. Cockup to stay firmly in the car park. However, he seems to have come in and started mucking about with stuff. Anyway, we shall continue. I do apologise for the YouTube cock-up there. It does turn out that a lot of people could see it, so I don't know what was going on. I don't know why only half people got the stream, so we're still trying to work it out. Anyway, let's have a look about what you can learn in the engineering degrees. Oh, no, actually, before we do that, we're going to have a look a little bit about what it's like to live and work on campus. Let's have a look. So what we're going to do now, I've actually remembered the script, is we're going to have a little bit of a look at the degrees that we do here in engineering. Now, engineering is a particularly interesting discipline because it covers a wide range of subjects, and we do a couple of them at Sussex. Typically what happens is you get one engineering school per discipline, but we actually group lots of things together, and we are in with computer science as well. So we can explore the technical and creative world from a number of different points of view, all at the same point of view. But let's have a look at the kind of degrees that we can do here. So we have actually 5 degrees which are coming up in the moment, and each one of these degrees has both a BEng and an MEng component. BEng is the Bachelor's of Engineering and the MEng is the Master's. Now they are accredited by the various professional bodies, i.e. the IET and the IMechE, which is your route to doing becoming a chartered engineer. Basically what you do is you do the MEng and then you can start the process. If you're like me and you only do the BEng, I don't know why I did that. You have to do something else. So I actually did the BEng, then I did a PhD, then I became a chartered engineer. But still, you know, you get the rubber stamp at the end of the day anyway, which is great and it's fun and you can stamp it on stuff and other things. So you don't need to decide right now which degree you're going to do, which is why I'm not going to spend too much time on the individual ones. The idea is that you can come on to any degree and switch around in term 1 when you've really decided what it is you want to do. You might know now, you might know exactly what you want to do, but at the same time, you might just know an approximate area. And then throughout the degrees, there's options and abilities to fine tune that into the area that you want to be able to do. And one of the reasons we can do this is because of the way the school and the departments are aligned. So for example, we have electrical and mechanical engineering under one roof with computer science. And that means that there's a whole load of interesting stuff all happening. I would say one building, but I think we're in about 9 buildings, but all happening under one roof that isn't joined together, but could be if somebody built a massive roof. Okay, so let's have a look at what you can expect from being here at Sussex. Well, we want you to be the problem solvers of the future, and I think you will be when you come here and do a degree, because we try to foster in you that ability to think creatively around problems and produce interesting and novel solutions, and hopefully you'll see today some of the ways that that has been done. We do this by being friendly and approachable. You can come and say, I have an open door policy, it's open at midnight until 1 minute past. No, that's a joke. You can come and talk to us at any time, and in fact the great thing is that because there's so many people in all sorts of different disciplines, you can just wander around the building and find, if you're stuck on something about networks, go and find Ian. He'll tell you all about it, and that's the kind of thing you can do. You guys are enthusiastic and motivated students. What does that mean? It means you turn up and smile and have a nice time. And actually, we're getting loads of questions in and stuff like that, so I know you're already enthusiastic and motivated. So let's have a look at the way the terms work here at Sussex. This is a typical year. You have the autumn term and the spring term. We don't do winter, because that's a bit cold and horrible. So what we do is we call it autumn, and then we bang Christmas up to that. We also have some assessment periods there. You can see the things marked in A, and the assessment happens at the end of each term. So you don't have to wait until September before you are assessed on something that you've learnt at the very beginning of the term. Now, if you multiply these by 3, you then get what the BEng looks like, i.e. 3 years. Then if you add another year, you get what the MEng looks like. Then, if you want to do a placement year out in industry, like as Ian was describing, we jam it there between years 2 and 3. And again, this is another part of the configuration of the degree. It really gives you that idea to decide whether that's the path you want to take or not. So it's a really good experience of real life, and decide whether you are on the right sort of course. Now, one of the things that we do to help with the whole creative thinking in this world of engineering and technology is we have the Global Design Challenge in basically the assessment period of the first year, the first term. So it's the first time you're being assessed. And what you do is you get to look at some interesting stuff in a specific area. I can't say more of that because it's normally a secret. But we'll do a little bit of an overview of that later on. We also have in year 3, we have individual projects where you then get to choose your own thing that you make, and you can pick any academic around and do a project with them. And then you do a group project for the MEng there at the end of the 4th year. Let's now start by looking at the individual degrees, and we're just going to do a quick overview of each one so we don't get too boring. If you want low level details, then you can have a look at the prospectus. These are the kind of areas that we learn and that we teach and that you will learn in. Now, one of the interesting things is that quite a lot of optionality around here, again, to help you tune this to the kind of first steps career move that you want to make. So one of the things we do is CAD. Now, CAD is a very interesting thing because a lot of people think CAD is about building 3D models of something you're going to make, which it is, but it's not only that. This, for example, is a thermal model of actually the inside of a jet engine. And what this is doing is this is using computers to aid the design, obviously, which is what CAD stands for, but it's doing it from a totally different point of view. We're seeing what might happen if we were to do a certain mechanical thing, and then you can make changes to the 3D models to see what happens. So if we have a look at CAD from a 3D point of view, you can then go off and make some interesting stuff. And we have two ways of doing this. You can either do it in the CNC lab where you can do it yourself. You get in there, you can use the materials, the expert technicians will explain how the new machines work, and you can try things with the new machines, maybe get different stuff out of it that you've never tried before, or in fact like Lucy, you can just invent a whole new material. It doesn't really matter. The other way that you can work, and this is something that you will find more attuned to being a professional engineer, is taking those skills that you've learned and that you've understood, but then applying them to real world production, which is where you have to then go and hand that over to a production facility. And we have a production facility on campus, which is run by Liam here. He will take your CAD work and your designs and everything, and will then manufacture them for you. So you have to make sure you get that right. And this is an example here of one done by Chris, I think. The graphics might have got a bit stuck there. Oh no, there they go. And this is the front brake assembly system of a car. This is what he designed here. This is the CAD. And then you can see in this next picture, the picture of it attached to the car. So this is what Liam and his colleagues made in the workshop. And you can see it here in the larger context of the car. And actually, this is a picture of Chris sitting here in the team captain position of the car. He's sitting there in the driver's seat. I don't know whether he actually drove. I think he was the team leader. But he actually went off to work on work for Ford Motors. And we all like a motor, particularly a jet engine motor. And we have not just jet engines that we can research, we have jet engines that you can play with. This is a really cool machine. It goes very fast, it's very loud, and don't stand at the hot end. Now, it will fire out some fire at the end, but apparently that's not always supposed to happen, apparently somebody said, but I thought it looked cool, so I left it in the video. Anyway, I'm not actually a jet engine engineer, I'm an electronics engineer, so I just look at that and think, well, that's pretty cool, isn't it? Let's talk about electronics for a moment. So electronic engineering, and I said this is the route I did, I'm a chartered engineer in electronics, and you can learn a whole load of stuff in electronics and electrical engineering, which is around in that discipline. And we have a whole set of labs, actually, that we can never really show them all at the same time because they sort of pop up and pop down depending on what it is that we're going to teach. This is an example here of a signal processing lab where we're doing DSP. So we've got digital signal processing board where you can write software, or you can do VHDL and develop FPGAs and that kind of stuff, program the boards and then evaluate it. Now, if you take the electronics and electrical engineering and you take the mechanical degrees and then you put robotics on them, we have another two set of degrees there. So it's the mechanical engineering and electrical with robotics. And the robotics degree has a whole another set of systems that you learn, but specifically for the robotics, we're looking at the combination of the two. So from a mechanical point of view, we might be looking at the mechanical stuff and how that might integrate with the electronics, but from the electronics point of view, we're looking at building the electronics and how that might integrate with the mechanics. So it's kind of the two things, the same but different, you know? And we have a great lab to do this in. There's a whole load of facilities that you can look around. So there's a production facility that you can work with, so robotic production, but we also have fixed robots so you can just sort of program up. And then one of the things that we do is we do a lot of extracurricular activity as well. One of the societies that you can join is RoboGirls, and this is set up actually by Emma, that you'll see in the next picture actually, and you can you basically get to play with robot gear, and it's extracurricular. You're not assessed on it. It is for fun, but we do support it as a school. So we pay for it and fund it, and it's a really good way to meet people and do that cross-discipline collaboration and really understand how to work in something that it doesn't really matter because it's just for fun. So it's quite a cool thing to do. Now, individual projects, they're interesting things because they happen in year 3, and that's your chance to turn it from being a generic degree into something that is really focused on what you want to do. So this is a project here that I think Sophie did, which was to produce a robot that travels around on a spherical sort of ball type system. That was the CAD, and this is a photograph of the actual project. And she did mechanical engineering actually to start with, but her project is very, very cross-discipline. So as you can see there, she's got, that's a Raspberry Pi, actually not an, somebody said it was an Arduino, liars. A Raspberry Pi, some power electronics to make it run. There's some 3D printing there to make that work, and also of course some stepper motors, and driving stepper motors is difficult enough in its own right, let alone getting them to all work in the same thing to actually move a robot around. So it's quite an interesting project. Now that's what you do in the 3rd year. If you go to the 4th year, you do the MEng group project. This is where it becomes much more of a complex project because you have to work in a group. And this one is one that I named, because they didn't give me a name, so I've called it No Tower Power, because it's a power generation thing without a tower. Good naming, yeah? I should be doing names for a living. Anyway, inside you can see that it's got a turbine that is particularly similar to the kind of thing you might see offshore. We've got a particularly nice offshore wind farm actually in Brighton. I'm particularly like driving down the hill thinking, oh, all my power is generated by the wind. But this one here is, you fly. Now this is the first prototype, and it's done with a helium system, which means it's particularly expensive. The next one, though, that they're working on right now is a fixed wing system. So it actually uses the standard laws of aerodynamics to keep it. It literally flies. It generates its own little bit of power to keep it up there, but it generates far more power than it requires to keep it up there. So you can just hoist this up quickly, and the idea is to hoist this up in sort of emergency situations where you need a bit of extra power or where there's no power at all. It does have to be windy though. Right, so what's next? Global Design Challenge. Now the Global Design Challenge, this is another part where you can really get to understand how to work in a team and fix some really interesting problems. Now, one of the interesting problems you get is with the level of technology that's used. And we quite often show this picture and people go, oh, that's a really old mobile phone. Don't you know what a mobile phone looks like? So obviously we know what a mobile phone looks like. But there's a reason why we use an old mobile phone, because where do all the old mobile phones go? They don't go to the mobile phone heaven. They generally go off into developing countries. And there's loads, millions and millions of people in the world that are using 20-year-old technology, but that need solutions now, today. So actually one of the big problems is, how on earth do you program a phone that's 20 years old? I mean, do even the SDKs exist? I don't know. So there are very interesting problems, very interesting challenges to solve, certainly engineering and software-based projects around this area. Now, oh, this is the kind of thing that you do. This is picture here. You might think it's a bit staged, and that's because it is. That's because what I was supposed to do is take a picture at the design challenge, bot for bot. So I had to get Kobe and Chloe to sit there and make it look like they were there. But you get the general idea. You basically sit around with your mates and you design something that's quite cool. And I think that is quite cool. So let's have a look at our final degree, which is automotive engineering. And again, this is very similar to the way that we made the robotics degree. This is a combination of the electronics and the mechanics, but it's specifically targeted towards vehicles and what we might need to do there. Now, this is the kind of stuff you'll learn, but it's much better to learn in practice. Of course, we have a whole facility for doing testing of engines, and this is both from the electrical point of view and also from the internal combustion engine point of view. But there's a much more fun way to learn automotive engineering, and that is to build a racing car, and this is Formula Student. And Formula Student is your way to go to Silverstone and race a car. Look at that. I mean, that's just awesome. And you get to go there, and that's fun. Now, we do two types of car. There's the combustion engine car, and we also do the electric car, because let's face it, it's the future. And the electric car, which I don't know what's happened to graphics, I think they might have got a bit stuck. But we have an electric car, and it is, I mean, the thing about the electric car is the torque on an electric motor is phenomenal. And that means the acceleration is mind-numbingly exciting. I mean, if you can survive it and your whole face doesn't get laminated to the back, then that's really cool. So that's the electric car. The last thing we've got is here, which is Becky. She was the team captain Formula student, and now she works as a special mechanical design engineer. Now, what I've just done, rather stupidly, is smashed my AirPod out of my ear onto the floor. So I'm just going to have to go down here and pick it up for one small moment. Back in a mo. There we go. Nothing like professional studio environment. So now we have a couple of questions coming up. So I'm just going to talk to Ian. Let's just bring Ian in. Can I just have
Can you show us the rabbit that sits behind you?
So somebody's asked whether they can see the rabbit that sits behind me. It's not a rabbit, it's a small dog, and unfortunately, what?
The rabbit.
The rabbit. Oh, the rabbit. Oh, the rabbit on the shelf. Yeah. Okay. Well, hold on a minute. Hold on a minute. I mean, I do have a small dog, and he's literally. The trouble is, right? Normally, when we do this, we're in a nice studio environment. You know, we shut the door. We say, "Don't blooming speak." But now we have to. Anyway, here's a nice little rabbit. There we go. Can you see that? We did have some other questions. Okay, so the next question is, let me have a look on my list. The next question is, can you tell us about the A-level requirement? Ian, you're going to have to do this, I know nothing about it. What do we do about the A-level requirements for the engineering degrees?
Okay, so the A-level requirement, so as everybody knows, the COVID-19 approach to A-levels, your assessments are being used for your in-class assessments to actually, by your teachers, to pull together an output which Ofqual are happy about as a sort of as a way of actually saying what your level is. We're currently expecting your offer is probably ABB or BBB. We're expecting to be taking people in. What happens is the universities all get together and look at the people that have got their sort of offers in just before the 13th of August. And then we make a decision about sort of what level do we actually want to accept at as a university. I expect it this year to be BBC, possibly a bit lower than that. And that will happen on the 13th of August, and you'll find out at sort of just before 8 o'clock whether or not you've been accepted into Sussex. Of course, if you don't actually make the first year offer of BBB or BBC, we will also offer you the possibility of coming to do a foundation year, where you study in the University of Sussex, you're a full-fledged student, but you do an additional year that prepares you to step into year one and hit the ground flying. And many of our best students get the best outcomes are people who came through the foundation years. Okay, Phil, next question.
Well, the other question was actually about how COVID-19 was going to impact it. But I think we should probably, I mean, you kind of covered it, but do you want to just give an overview of what we're planning to do for year one in September?
Okay, so at the moment, we're hoping that we're going to have everyone coming onto campus, so that you'll actually be staying in the residences, whether it be on East Slope or Northfield or wherever. But the actual teaching, we're expecting to try and figure out how to do this in a way that's socially distant. So what will happen is, rather than having crowded lecture theatres, we will be doing the big lectures online and do remote delivery of sort of lectures. But then we will compensate for that, having more time in the labs, more time in seminars, more time actually spent in a room where we can socially distance you. So you can work in a lab that's 2 meters away from your neighbour. You can come into a seminar that's 2 meters away from your neighbour as well. Okay, does that make sense?
Makes sense to me. I think that's going to be pretty good. Thank you very much, Ian. And thank you very much, everybody else, for watching. I'm terribly sorry that Mr. Cockup did pay a small visit, and I will be having words with him later because he's not allowed to come back again. But for now, thank you very much for listening. Hope to see you soon. Bye-bye for now.